Welcome to IT.Solution, your total network, system, firewall, and security partner.
Welcome to this explainer. Today, we're going to talk about a process that is just incredibly satisfying if you love structure and building things from the ground up. We're looking at basic router configuration, specifically configuring a Cisco IOS router from scratch. I actually like to think of this as digital house flipping. You start with an empty, totally non-functional property, and through a series of really structured steps, you transform it into a secure, fully operational hub of activity.
Okay, let's dive into this. Imagine you just unboxed a brand new $5,000 enterprise Cisco router. You plug it in, you connect some cables, and, well, it does absolutely nothing. No traffic is routed, no packets are forwarded. It's essentially a very, very expensive brick. Why? Because unlike that basic home Wi-Fi router you might have, an enterprise device completely relies on you to define exactly how it should operate. Out of the box, it defaults to a locked-down, deactivated state. So where do we actually start?
Here's our procedural blueprint for today's digital house flip. We're going to move through 5 distinct phases. First, accessing the router CLI. Second, securing the device. Third, configuring network interfaces. Fourth, setting the default gateway. And finally, verifying and saving our configuration. Phase 1. Accessing the router CLI. Entering our empty house and giving it a proper identity.
So when you first log in, you are greeted by this really simple prompt, the word router followed by a greater than sign. This tells you you're in user exec node. Think of this as standing in the foyer of that empty house. You can look around, sure, but you have literally zero administrative power. You can't change any configurations or knock down any walls from this spot.
To actually get to work, we need to upgrade our privileges. By typing Enable, we move to Privileged Execute mode, and then by typing Configure Terminal, we enter Global Configuration mode. Notice how the prompt changes to Router Config hashtag? That hash symbol means you now hold the master keys to the house. Any commands you type right here affect the router globally. Now, the very first thing we do with our master keys is give the router a name. By typing hostname R1, the prompt instantly changes from the generic router to R1. It's a simple command, but honestly, it is absolutely crucial for organization. When you're managing a network of dozens or even hundreds of devices, you need to know exactly which house you're standing in at any given moment. With that, our router has an identity, and phase 1 is complete. Moving on to phase 2, securing the device. Because an open house is dangerous, we need to add some locks. Right now, our digital house has no locks on the doors. Anyone could walk right in. To fix this, we need to implement 3 mandatory levels of password protection. First, we have to protect those master keys by securing privileged exec mode. Second, we need to secure the front door by password protecting user exec mode. And third, we absolutely must secure the virtual backdoors by protecting remote access. Securing remote access is a big deal because network administrators usually configure routers remotely via virtual terminal or VTY lines. So we enter the VTY line configuration, set a password, and require a login. Now, notice that last point, transport input SSH telnet. SSH is heavily preferred here. Why? Because unlike telnet, SSH provides encrypted remote access. It keeps all our keystrokes perfectly safe from any digital eavesdroppers. But even with our passwords set, we have 2 more security housekeeping tasks to take care of. We use the service password encryption command so that if a shoulder surfer somehow looks at our configuration file, they just see scrambled text instead of our actual plain text passwords. Then we hang a banner MOTD, or message of the day. This isn't some friendly greeting. It's a strict legal warning to unauthorized users that accessing the system is completely prohibited. It's basically the digital equivalent of a massive no trespassing sign. Phase 3, configuring network interfaces. It's time to pave the driveway so traffic can actually enter and exit.
Right now, our router is perfectly secure, but it's totally isolated. By default, all Cisco Enterprise router interfaces are turned off. Their digital doors are closed tight. To make an interface operational, it has to meet 3 conditions. It needs an IP address and a subnet mask. It must be explicitly turned on using the no shutdown command, and there must be a live physical cable plugged into it. Here is the exact syntax for assigning that address in interface configuration mode. We type IP address, followed by the IPv4 address and the subnet mask. And you know, it's worth noting that if you were setting up an IPv6 network instead, the logical structure is practically identical. You just use the IPv6 address, command, and format.
Now, what's really interesting about this concept is the loopback interface. Unlike a physical gigabit Ethernet port, a loopback is a purely logical internal software interface. And because it's software, it never relies on a physical cable. As long as the router has power, the loopback interface is up. This gives us a permanent, never-failing IP address that administrators can use to test internal routing processes or just remotely manage the device without ever worrying about a physical cable getting unplugged.
Phase 4. Setting the default gateway. Giving our router a map to the outside world.
Okay, so our router's interfaces are up and running, but if it receives a packet destined for an unknown network, it needs a map. Let's talk about the default gateway. For any host device, like a typical PC, the default gateway is simply the local router's IP address. If a PC wants to talk to a device on its own local network, it just sends the traffic directly. But if it wants to reach a web server out on the internet, it sends the packet to the default gateway, essentially saying, hey, I don't know where this goes, you handle it.
But it's vital to remember that end-user PCs aren't the only devices that need a default gateway. Even Layer 2 switches, which primarily operate on MAC addresses on a local network, they require a default gateway if you want to manage them remotely from a completely different network. Without this specific configuration command, a switch literally wouldn't know how to reply to an administrator logging in from a remote office.
Now, for the router itself, this concept is implemented as a default static route. The syntax uses a quad 0 address and a quad 0 mask, 0.0.0.0, 0.0.0.0. This translates to match absolutely any IP destination. So if a router's routing table has no specific match for a packet, it will forward it to this gateway of last resort, which is usually the service provider's router leading out to the broader internet.
Finally, Phase 5, verifying and saving configuration, taking the picture and locking it in.
Our digital house is fully built and mapped. Now we take that final inspection photo to prove it works. By issuing the Show IP Interface Brief command, we get a really clean summary of our network ports. Look at Gigabit Ethernet 0/0/0 and 0/0/1. They have IP addresses assigned, they were manually configured, and most importantly, both the physical status and the line protocol read as up. And this brilliantly illustrates our payoff. That up state means our interfaces are completely healthy and ready to route packets.
But hold on, we aren't done yet. Right now, all those commands we just typed are living in the router's RAM, in a temporary file called the running config. RAM is volatile memory. If someone trips over the power cord right now, our beautifully flipped digital house completely vanishes, and we are right back to a blank $5,000 brick. We have to move our work to the startup config, which lives in NVRAM, or non-volatile RAM.
This is the command that locks it all in for good. Copy running config startup config. It takes the active working memory and writes it directly to permanent storage. Now, when the router reboots, it reads this startup file and instantly restores our hostname, our encrypted passwords, our interface IPs, and our default routes. The house flip is officially closed, saved, and ready for move-in.
You've successfully mastered the structured logic of the Cisco CLI, getting this single router perfectly secure, addressed, and routing traffic. You understand the foundational mechanics now, but let me leave you with a final thought here. Configuring one router by hand took us, about 10 minutes? What happens when your company asks you to deploy 500 of these across the globe by tomorrow morning? That is exactly where the magic of network automation and programmability comes in, and it just might be the topic of our next explainer. Until then, keep learning and keep building.
Thank you for watching. See you in the next episode.